Hello everyone. Thank you for joining us at reInvent today and this VMware Cloud on AWS session. My name is Arti Raju and I lead the Solutions Architecture team focused on VMware Cloud on AWS. For the last 4 years, we've been working with customers and partners to understand their migration requirements and helping them move into the cloud using VMware Cloud on AWS. What I wanted to share today is some of the architectural patterns, lessons learned that you can take as you think about migrating your workloads into the cloud. We'll also talk about some of the critical questions that you should be asking as you're planning this migration journey and some technical resources towards the end of the session. When we talk to customers, the first question I typically ask is, what network architecture is right for me? There are different options available for customers depending on what they need, and that's what we'll cover in this section. Before jumping into the network architecture, I want to quickly level set on some of the building blocks we are going to be using throughout this session. AWS has the concept of a region. So here you see a corporate data center. So this could be a customer's on-premises environment. And with the concept of region, these are physical locations around the world, and each region consists of multiple isolated availability zones. An availability zone, or AZ, as you'll see me refer, is one or more discrete data centers with redundant power, networking, and connectivity in an AWS region. Within this region, you'll see the virtual private cloud. So this is a private isolated environment that you create for your workloads. The VMware Cloud on AWS software-defined data center also resides within this region, and it resides within a VPC that you create. So we've got the VPCs, we've got the SDDC. What are some of the additional building blocks that you are going to be seeing? The first one is an NSX edge. So when you bring up a software-defined data center, the NSX edge is part of the deployment, meaning you don't have to create this NSX by yourself. It enables you to terminate any traffic that's coming in and out of the SDDC. The next is a customer gateway. A customer gateway is a device that you own on premises in this data center box that you see here. So this could be any firewall or a router that is capable of terminating a VPN traffic or terminating any traffic that comes into your environment. The next is a virtual private gateway. A virtual private gateway is the termination point for traffic coming into a VPC on the AWS side for your VPN connections or for your Direct Connect. The next is AWS Direct Connect. So AWS Direct Connect is a private connection that allows you to get dedicated bandwidth, either a 1 gig or 10 gig or multiple 10 gigs or even sub 1 gigs through our partners. What this allows is, and why this is important is, especially for migrations when you're looking at transferring data from on-premises to VMware Cloud on AWS, you want to have a consistent network path. The next is an elastic network interface. An elastic network interface is a virtual network interface that gets attached every time you create an EC2 instance. It has certain attributes like a private IP address, a public IP address, MAC address, etc. The next is AWS Transit Gateway. We launched AWS Transit Gateway last year because our customers wanted to have this central hub that takes care of routing for them, traffic coming from on-premises, between VPCs, SDDCs, etc. So we'll jump into the AWS Transit Gateway's details as we go further. You are going to be seeing this design bubble in every slide. This is an architecture session, and the design bubble will talk about some of the key considerations for that architecture. And going back to our tenets that you saw, what questions should you be asking as you're building on this architecture? With that said, the first requirement is, how do I connect my on-premises to my SDDC? So this could be one SDDC or this could be multiple SDDCs. So you see our building blocks here. You have our on-premises environment, you have my AWS region. So within this region, I'm building up my VMware Cloud on AWS environment. I have multiple SDDCs. So first method of connecting between your on-premises and these SDDCs is using a VPN connection. So the VPN connection terminates on the NSX edge on the SDDC side. And let's look at the design bubble here. So this is a layer 3 VPN connection, meaning you can select it to be a route-based or a policy-based VPN connection. Key considerations is, and the questions to ask is the bandwidth requirements. VPN connections, as you know, it goes over the internet. So when you plan for this kind of architecture, you have the bandwidth limitations that could occur either at your on-premises, depending on the type of device that you have and the ISP connection, and on the NSX edge as well, depending on how much packets that you are sending and migrating. We recommend customers to think about doing a stress test as they think about using VPN as their connectivity model. The last thing is high availability. You have a single VPN connection between your on-premises environment and the VMware Cloud on AWS SDDCs. So think about how you will build HA, either having multiple customer gateways and also multiple tunnels. As we progress in this architecture, we talked about that bandwidth being a key requirement for migrations. And this is where we want to introduce AWS Direct Connect. AWS Direct Connect, as I mentioned, this is a dedicated 1 gig or a 10 gig connection that you can purchase from AWS. And AWS will give you a letter of authorization that you take to a colo provider like Equinix or Level 3, and they will help you set up that last mile connectivity. So from the co-location to your on-premises, you will have last mile connectivity. This could be a point-to-point, this could be an MPLS ring. And then from the Direct Connect location into our AWS region, we will guarantee that bandwidth that you purchase. Let's say it's a 10 gig connection. So you get a 10 gig connection into your VMware Cloud on AWS SDDC. So looking at the bubble, design bubble now, we've covered that bandwidth. You now have the dedicated connection that provides you that bandwidth that you've purchased. The next is cost. So Direct Connect does incur costs. So you pay for port charges for the speed that you're using and also for data transfer out. Ingress is free. Data transfer out, there is a cost associated that is much reduced than the internet rates. In terms of high availability, this is a single point of failure. You have one Direct Connect that's at a single location. So how do we architect for high availability? We recommend customers to have multiple Direct Connect locations, use multiple Direct Connect locations, and get into this kind of architecture where you have two DX connections and you have multiple interfaces that you create to these software-defined data centers. If we look at the design bubble now, we've taken care of the HA requirements. We have multiple DX locations, so that's taken care of now. You can use route priority to prioritize, like you can use AS path prepending to prioritize which path that you prefer for your traffic. And then, if you feel, we do have customers who don't need multiple DX connections. So in that case, we also tell customers that they could use VPN as a backup instead of having multiple DX connections. But key things to remember there is you're now switching, let's say you have a 10 gig connection, you're now switching from a 10 gig to a much lower bandwidth. So you have to plan for how this is going to impact your application if there is a failure at the DX Connect location. So we've covered on-premises to this SDDC. How about customers having multiple SDDCs that need to communicate with each other? Given that there is NSX edge at each of these SDDCs, customers can simply create a VPN connection between these SDDCs. So going back to our design bubble now, this is again a layer 3 VPN connection. So you have the bandwidth that comes in. So NSX Edge is capable of doing up to a certain amount of bandwidth, depending on the host type that you have, whether it's i3 metal, i3en.metal, and also the number of packets per second that you're sending across these edges. There's also a limit on the number of VPN connections you can have as you grow these SDDCs into larger amounts. The next one is from your SDDC into your customer VPC. And this is a very important ask from our customers because a number of our customers want to connect to AWS, native AWS environments to communicate to AWS services. So when we built the service, we wanted to make sure that's taken care of and automated for customers. So what we did during the onboarding process, as you go through your SDDC deployment, you'll see that you will run a CloudFormation template that creates IAM roles and access for VMware with limited privileges and permissions. And what we do in this process is we create elastic network interfaces in a VPC that you select. So that's what you see in the diagram here. These are directly attached to the SDDC ESXi host running within this SDDC. What this gives you is that direct private connectivity using an elastic network interface that provides 25 gigs of bandwidth on an i3 metal, for instance. So you're not using internet gateway, you're not going out or tromboning and coming back in. Because both of these environments reside within the same AWS region, we're able to provide you this direct connectivity method. Some of the considerations is this is an ENI connectivity, as I mentioned. So it's private connectivity, so you don't have to worry about assigning public IP addresses. This uses the Amazon Elastic Enhanced Networking Adapter. And then in terms of the cost, when you do data transfer between your SDDC and your AWS region that are within the same availability zone, there's actually no cost associated with it. But if it's within different availability zones, then there's the standard AWS data transfer cost. From a scalability perspective, this is a 1:1 scalability model. Like, we don't see this model scaling to like having one SDDC connect to a number of VPCs or the vice versa. So what we wanted to do as we build for scalability is use the transit gateway, and I'll get into the details of that. But what we've also seen customers do is, hey, I also want a VPN connection between my SDDC and my AWS VPC. On the SDDC side, you've got the NSX that's capable of doing layer 3 connection, VPN termination. And on the VPC, customers can create an Amazon Virtual Private Gateway, which was one of our building blocks that we saw, and create this VPN connection. The bandwidth comes in as a key requirement here, right? Like, as you're thinking about like what workloads am I going to like backing up to AWS? The bandwidth on the AWS Virtual Private Gateway is at 1.25 gigs. And on the NSX, as I mentioned, it depends on the instance type that you select. So plan for that connectivity model. As you plan for this model, think about the bandwidth. In terms of HA, you could create multiple VPN connections. But as we think about that scalability model here, this is where I want to introduce you to the VMware Transit Connect. So the VMware Transit Connect uses the AWS Transit Gateway that I discussed on the SDDC side. So if you think about this, we've got multiple SDDCs. And what I do is I've got my VPCs, I've got my on-premises environment. We introduced this concept called SDDC grouping. So within this SDDC group, customers can select the SDDCs that they want to communicate with each other. So as you select these SDDCs, it's put into a group and a transit gateway is created. So the Transit Connect comes up and you attach your SDDCs, and also this allows you to communicate with your on-premises. So we're now eliminating VPNs completely out of the picture. What also it does is, remember the ENI connectivity model is, I mentioned it's a 1:1 model, doesn't scale really well for a lot of VPCs. So the Transit Connect allows you to attach multiple VPCs that you own. You could own 50 VPCs or 100 VPCs that you own into the Transit Connect. So if I bring this all together, how this Transit Connect helps us solve like on-premises and SDDC to SDDC and SDDC to VPC, we've got multiple SDDCs here. So you create the SDDC group, which creates the VMware Transit Connect, and it gets attached into the Transit Connect. This provides you the ability to communicate within the SDDC. The design bubble here, as you see, the Transit Connect or the Transit Gateway is a regional object. So these SDDCs have to be within the same region. And this Transit Connect is managed by VMware, so you don't have to go in and like change routes or update routes, etc. And we talked about the concept of SDDC grouping. Now, we also want to see how it works with our VPCs, the customer's native VPCs that you might have. So the Transit Connect can be shared with your AWS account. And once it's shared, you can attach any number of VPCs that you own into the Transit Connect that requires connectivity to the SDDC. So the traffic pattern is important. One of the key things to remember here, this Transit Connect as it's a connectivity between the VMware side of things and AWS side of things. So in this, SDDC to VPC connectivity and the traffic flow will work, whereas VPC to VPC will not work. You will need your own transit gateway to control that traffic. But this solves for a scalability problem, like we don't have to create these one-on-one connections anymore. And then putting this all together, so we've got the SDDCs, I've created my Transit Connect, attached it, I've got my VPC, my workload VPCs that I've created, I've attached it to the Transit Connect. But I also need my workload VPCs to communicate with each other. So I've created my own transit gateway in my account. and attached it. So this provides communication between VPC to VPC that I own. Now I'm also solving for the on-premises connectivity. So I've created direct connect across 2 locations. I've created a direct connect gateway, and I have these virtual interfaces, transit WIFs, that connect into this transit gateway. So what this does is it gives me that full picture of connectivity from on-premises to VPCs, workload VPCs that I own, and also it gives connectivity between SDDCs to SDDC and SDDC to my VPC. The next thing that we want to talk about as we finish the networking section and talked about the connectivity models is how do I think about storage when it comes to an evacuation of a data center to AWS infrastructure or hybrid architecture for workloads running on premises and for services in AWS. Now, if you look at the diagram here, this is an architectural representation of a hybrid cloud deployment. The patterns as well as design principles would apply for a DC evacuation use case as well. So on the left, you have the data center, and on the right, you have the AWS infrastructure, which is where the VMware Cloud on AWS as well as native AWS services reside. With the data storage aspect, there are 3 specific tasks that customers would have to undertake to embark into this journey into the cloud. The first step is migration of virtual machines. So once this data is migrated to the AWS infrastructure, they want to ensure that they have the highest level of availability, performance, scalability, cost optimization, and resiliency. And they also want to have this data protection strategy implemented on the data sets for the virtual machines. You want to make sure you take on the step of modernizing your data approach that is driven by your end user use cases. Now, the same design bubble will span across all these 3 specific tasks in the customer journey. So let's get into the specifics, starting with migration. What you see as we are going through these 3 specific tasks, the building blocks will follow. So you have the corporate data center and you have the AWS region. Now, a lot of you will be familiar with this construct. So in VMware vSphere, called the virtual machine disk file, the VMDK. You can have 1 or more of these attached to your virtual machines, and they would be the storage for the applications that run on the vSphere VMs. With VMware Cloud on AWS, we want to make it seamless to migrate these VMs from your data center to the cloud. So we don't want you to go through any conversion of VMDK into Amazon AMIs, Amazon machine images, or additional deployment of EBS volumes, and make sure you have operational consistency because you are running identical hypervisor on both environments. Now, we worked with VMware to enable these migration options for you to make it seamless depending on your use case. There is a specific tool set that will allow you to get from point A, which is on premises, to point B, which is the AWS cloud, and help you move these workloads without any downtime. So we have options like vMotion that works with Direct Connect integration that we've jointly engineered for. There's also VMware Hybrid Cloud Extension, HCX, which is another option that customers could deploy when they want to bulk migrate hundreds, if not thousands of VMs. So you select the VMs that you want in batches, select when to migrate and when is your cutoff. So without having to convert any mission images or modifying your runbooks, you now have seamless migration from your on-premises environment into the other. There are additional options listed here. Site recovery, which you might be familiar with, which is better known for DR as a service capability, which is an add-on that allows customers to have DR protection from on-premises to the cloud or even for their migrated workloads. You specify a group of VMs that you want to migrate and have data protection for. We also have Cloud Endure, which is a native AWS solution that has been supported for native migration from on-premises into native AWS. Last but not the least, another popular option for customers that have been using backup data protection integrated solution from our integrated solution vendors, ISVs like Veeam, Dell EMC, Commvault, Veritas, IBM Spectrum. All of these solutions have been certified and validated to run on premises and for VMware Cloud on AWS. So what we wanted to do is provide customers the choice of how they want to back up their copies of data into Amazon. And this is where we also hear from customers that they have other data sets, and this could be like unstructured file formats that is required for their application. So now we have designed a number of services to make this migration or ingestion of data into AWS easier. So we've got AWS Data Sync that allows customers to deploy a VM that they download from AWS, deploy it in their vCenter on premises, and then choose a destination like Elastic File System for NFS-based storage or FSX for SMB-type file systems that they can use and mount it on their Windows VM. We also have Amazon S3, which is highly durable and available object store, which is a popular option for data protection and data analytics needs. Now, one last thing here is we do see storage gateway commonly used by our customers as well for data protection purposes with file gateway, volume-based, or virtual tape libraries. It fronts Amazon S3 in the form of virtual appliance that you can deploy on premises and then export NFS shares to the VM or SMB shares to the VM through the storage gateway and migrate into various AWS services. Now let's talk about protect. As I have data ingested with VMDKs, there are several key design principles. First and foremost, the vSAN policy. vSAN, for folks not familiar, is VMware's software-defined storage solution that provides primary storage to your virtual machines running on the vSphere hypervisor. Now, vSAN policy applies when workload is being migrated to AWS, as well as when you're starting this migration process. So you can define how many failures the cluster or the data store can tolerate. Let it be 1 or 2. So by default, the policy is set to 1, which allows for 1 component failure. As a best practice, for if you're running more than 6 hosts, we recommend you to configure FTT as 2. We also get questions around the RAID configuration with storage. So the best practice is we recommend is RAID 6, which gives you a good trade-off between performance and availability. In the native AWS, we generally recommend our customers to deploy workloads across multiple availability zones. And for the same reason, we also recommend customers running VMware Cloud on AWS to use the stretch cluster feature that allows them to deploy their SDDC across 2 availability zones. Now, free space, the recommendation is to keep 25% free space for your SDDC cluster. Now, we've designed the service such that when your free space is down to 20%, then the Elastic DRS, Distributed Resource Scheduler, will kick in and bring up additional capacity. The third thing to keep in mind is to have regular backups. You have data protection, and the way to approach backups is to offload. What I mean by offload is that you're not going to run backups and store them into your recent data store, which serves as your primary high-performance NVMe flash storage. What you want to do is offload them to native AWS services that will give you the ability to consume storage services for your data protection needs. You can do this through the ENI, the Elastic Network Interface that we talked about in our networking section earlier, that is attached to each and every ESXi host, allowing VMs to have seamless access to S3, FSX, or EFS. So these are all built into the service. So when you start consuming native AWS services, you do not have to spend cycles worrying about infrastructure monitoring or keeping things highly available. So what do you think about as a customer in such cases is to learn the capabilities that are built in so you don't have to worry about thinking about high availability. We've got that covered for you. For FSX as an example, we've built in Windows Volume Shuttle Service, VSS integration, that allows for end user self-service restore of a specific backup snapshots. So you as an architect don't have to get involved in day-to-day operations. We've built in capabilities that allows you to do so. So as a customer, what you think about is, does the backup policy that is default meet my business needs? If not, let me configure that policy. So you set it and you forget it. And because the data protection will be done automatically on your behalf as part of the service. Same thing with EFS, same story. If you have files on the share for a long time that is not being accessed frequently, you can leverage data sync as an example to move them into infrequent access. So with that, you could archive upwards of 92% of storage cost savings. Last but not the least, Amazon S3, which provides you various storage tiers with standard, infrequent access, glacier, deep archive, all of which can be driven by lifecycle policy that you define. Now that we've talked about migration and data protection, let's drill into modernization. By consuming native AWS services, such as Amazon S3, for example, that we went through earlier, you've already paved a strong foundation to modernizing your data architecture. That's essentially step 1 and 2 in this slide here. Now, if you take it a step further and start building a centralized catalog of all your data sources with ETL jobs for your data pipeline, then you essentially venture into a data lake architecture that allows you to have data access across your teams to gain insights. Now, step 4 of the journey entails you to configure security policies of who has access into my data, who can actually access this centralized catalog of data. So services like the AWS Glue allows you to do this exactly with support for features like data encryption in transit and at rest. So with that policy set, you can also take care of compliance requirements. So if we bring all these pieces together here, on the left, you have your on-premises connecting to your service, VMware Cloud on AWS and native AWS services using a direct connect. And then on the far right, you have native AWS Analytics service. So if you do the first step of your journey, which is migration of your workloads, let's say it's a database workload, for instance. We mentioned how seamless it is for your database that's running in the cloud now. You could deploy a service called Database Migration Service that would deploy your application instance in the connected AWS account that you have and point it to the source database, which is running in VMware Cloud on AWS. What this allows is now you're ingesting data into Amazon S3 as illustrated here. Now, the last step is copying this data into Amazon Redshift cluster and allowing the Redshift endpoint to that will enable you to get business insights, and then you can feed this into Amazon QuickSight or Tableau depending on your choice of application. So all in all, we've gone through the journey of migrating your workloads as well as like relevant structural or unstructural data. How do you ingest this into AWS services? And then how do you actually build a data lake architecture and get business insights out of it? So that wraps up the session. As mentioned, we talked about the architectural considerations from a networking and storage perspective. And then we talked about what are some of the key questions. Remember the design bubble. And what are some of the key questions that you should be asking as you implement this architecture? One thing I did want to share in terms of resources is some of these architectures that we talked about. We've actually built reference architectures that are available to you at this hyperlink here. We also have a getting started page for VMware Cloud on AWS that you can use to get started to build a smaller environment and test and validate to see if your application works as expected, keeping in mind the design principles that we talked about. At any time, don't hesitate to engage with your AWS solutions architect who can come in and sit down and do a deep dive with you on what's possible, what are your best options from an architecture standpoint. Again, thank you so much for joining us today at reInvent and hope to see you soon. Thank you.